Today we are in lesson 2, thinking about, again, us being marine scientists and thinking about the Stellwagen Bank National Marine Sanctuary. Don't forget, we're trying to help the superintendent answer this big question. How do animals communicate across a distance? So we're thinking about the bottlenose dolphins, and we're thinking about how are they communicating with each other underwater. We know that they get separated, but we know that they find their way back to their mother again. So we need to figure out and do some research and observations on how are they communicating to each other? How are they finding their way back to each other? To help us with that research, we have some vocabulary words today. We have 2 vocabulary words. We have pattern, we have source. What does pattern mean? Pattern means the same thing happening over and over again. What does source mean? Source means where something comes from. We've seen this definition before. The solar panels definitely should make that connection for you guys. When we were engineers, this is one of our vocab words then. It means the same thing, where something comes from. These vocabulary words are going to help us understand and be able to answer this big question for the superintendent. We're also going to see these vocabulary words in our text for today, which is patterns in communication. We're not going to read the entire text today. However, we are going to read the introduction of the text to sort of just introduce us to waves and what waves are, and also what patterns and how patterns help people communicate. Let's go ahead and get into our text for today. Actually, before we get into the text, I want us to review our classwork. Here's our classwork. As usual, in our heading, we have all of the resources that we need. So you can go ahead and click the link here for your text, patterns, and communication. Our objective for today, I will be able to explain how a wave travels. Vocabulary, pattern, same thing happening over and over again. Source, where something comes from. We have our PDN. You're going to give me the definitions of pattern and source, and you're also going to answer the question of what you think waves are. These questions, you are actually going to reread the text if you need to, and you're going to answer these questions independently today. I trust that you will be able to turn in high quality work without my assistance for these questions. All right, let's go ahead and get into our text. Patterns in communication. These little bees look a little creepy to me. I don't know about you. We're going to read the introduction. I love the table of contents. Being a text feature is going to help us save some time. We're going to go straight to the page. I'm looking at introduction right here, which is on page 4. So we're going to go to page 4. I'm not going to click it up here because I see that this is page 3, so I just need to turn one page. All right, here's our introduction. Remembering as we read, pencil and paper will be helpful if you want to jot down some notes to help you answer your questions, because your questions are going to be heavily related to the text. So you see something, you read something, you want to pause, write it down, that it will be very scholarly of you. All right, introduction. Using patterns to communicate. As young children, we learn to identify certain sounds with certain types of animals. For example, cows make mooing sounds and ducks make quacking sounds. In reality, though, it's much more complicated than that. Ducks don't just make quacking sounds. They make many different sounds, and those sounds have many different meanings that other ducks can understand. A duck's body movements can send messages too. As they move and make sounds, animals use specific patterns to communicate with one another. Patterns is one of our vocabulary words for today, and communicate was our vocabulary word for yesterday. So I'm going to read that again because I think this is probably some key information. As they move and make sounds, animals use specific patterns to communicate with one another. For instance, many birds bob their heads or flap their wings in patterns that tell other birds they are looking for a mate. Many marine mammals use different patterns of sound to keep track of one another in the ocean. I'm making a connection here. This is what we're focusing on, right? Those marine mammals and that sound that they're going to use. Insects use patterns of sound, motion, and even scent to communicate. Like other animals, humans also use patterns to communicate. Human languages are patterns of words and sounds that convey meaning. And looking at the images on our page 4, we see some animals, right? And this human communicating. Turn to the next page. This book explores how different animals use patterns to communicate. It has 4 sections: marine mammal communication, bird communication, insect communication, and human communication. And I'm guessing that we're going to be very focused on the marine mammal communication. These are just a few interesting examples of animal communication. Other animals use patterns to communicate too. In fact, almost any animal you can imagine communicates with patterns of some kind. Looks like he's communicating in a very, well, I guess he may not be vicious, but those are some dangerous looking teeth right there. Flipping the page. Information that travels as waves. For communication to happen, information has to pass from an animal to one or more other animals. Sometimes the information passes directly through touch, but other times it has to travel across a distance. In most cases, that information travels as waves. When you think of a wave, you might think of a wave in the ocean or a lake. This is one type of wave, but there are many other kinds of waves, such as light waves, sound waves, and waves that carry electrical signals. I'm sort of connecting that to the times that we were engineers, and I'm thinking about light energy, sound energy, electrical energy. A wave is a pattern of motion and can carry information from one place to another. This might be something you want to jot down for one of your questions later. When a dog wags its tail, it is sending a visual signal to other dogs. That visual signal travels as light waves. When a dolphin makes a sound, that sound travels as sound waves. When you send a text message, that signal travels as waves that carry electrical signals. Making that connection to the dog wagging its tail, we dog owners have seen that many times. Going to the next page. Oops, come on. There we go. All these types of waves may seem very different. However, different types of waves have some things in common. One characteristic of all waves is wavelength. Wavelength is the distance from one peak of a wave to the next peak, as shown in the waveform below. Might be something you want to jot down. A waveform is a curved line that shows the pattern of a wave. Waves with shorter wavelengths have shorter distances between the peaks. Waves with longer wavelengths have longer distances between the peaks. In a sound wave, the shorter the wavelength, the higher the pitch, and the longer the wavelength, the lower the pitch. Another feature of all waves is amplitude. This is a word that we're going to need to get familiar with. Amplitude is related to how much energy the wave has. In a sound wave, the amplitude of the wave affects its volume, or how loud the sound is. The louder a sound is, the more energy the wave has, and the bigger the wave's amplitude. Quieter sounds have less energy and smaller amplitudes. In the waveform below, which we'll take a look at, you can see how amplitude is represented. All right, when I'm looking at this wavelength, I see the peak, right? So they're talking about the distance, and I'm thinking about the distance from one peak to another. And those dips seem to play a role there. So in a waveform, wavelength is the distance from one peak of a wave to the next peak. So you have one wave here, and then you have another wave there. Thinking about amplitude. In a waveform, amplitude is represented by the height of a wave, measured from the middle of the peak. So here you have waves that are closer together, and they're going up and down, and the amplitude is based on the height of that wave. All right, we are done with our text for today. Let's go ahead and get into some examples. In class, we would have actually done sort of an experiment in figuring out how waves, or sort of having a visual of how waves work. And since we're not in class, we actually have some videos that I want us to take a look at. But before we do that, I want you to think out loud, very loudly. Where have you heard or seen waves before? And this answer may have already been in the text, and that's okay. But I want you to make a personal connection. Where have you seen waves before? Or where have you heard of waves before? So I know I've seen waves definitely in the water, going to the lake in the summertime, and on maybe a windy day, you've seen larger waves. And so that would be my connection. Let's go ahead and get into our videos today to help us understand these diagrams and how these diagrams work. The first one we're going to look at is actually more so the rope experiment. In this rope experiment, I want you to really check out the waves and how the waves are moving. So look at those waves, right? We see how those waves are moving. All right, let's go ahead and look at this slinky experiment. And so this slinky is also going to play the role of a wave and how waves can actually function as well.
Longitudinal wave. So in this case,
so when we think about that slinky, the slinky can actually move. This slinky was actually moving in one direction, but we know that if we know anything about slinkies, we know that the slinkies can actually bounce back towards the starting point of where the movement was going for that slinky. So those are two different examples that's going to help us understand the diagram in our slide a little better. So when I'm looking at the waves diagram and we're thinking about the two different types of waves that can happen, whether it be water or whether it is a sound wave, whatever type of wave it may be, A is going to actually represent the slinky. And A is going to represent the slinky moving back and forth. So it's going to go straight out, just like we saw in the video. And it has the potential to actually bounce back towards, back towards the hand, which can also create a little tension in the middle. And that is how waves, as we get deeper into this unit, we'll notice that sometimes those waves like that can actually be a little dangerous, right? If it's water waves. So this diagram A actually represents the slinky, and it represents the direction of a wave going back and forth and actually coming from forward to backward and creating tension right here. The slinky is going to represent the diagram B. So here, I'm sorry, not the slinky. I'm sorry, guys. The rope. The rope. The rope is going to represent diagram B. When the rope went to move, when the guy used his hand to actually move the rope, if he had the rope standing up towards the way his body was, it would have actually gone up and down. We saw it from a different angle, but if we had looked differently, it would have gone from up and down. So we have diagram A, the slinky was moving back and forth, and we have diagram B, the rope was going up and down. And so those waves are actually different. And those waves, us being introduced to these two different types of waves, is actually going to help us figure some things out in the future. As we think about those two diagrams, I want us to think about the source of the diagram. The source of the diagram, if we think back to our vocab word, source is where something comes from. The source of those waves was actually what? Where did those waves come from? The waves came from the hands, right? The guy used his hands for the slinky in the video, and the guy used his hand for the rope in the video. So their hands was actually the source. As you answer, sorry y'all, so you heard Pepper. She heard somebody outside. As you complete your classwork, again, I want you to think about I want you to reread the text and make sure you are answering your questions with high quality. Please give me sentence starters and don't forget your